We next want to look at finding probabilities based on tables. And just in the box here, the theoretical and probabilities and or probabilities, so there's this idea of ands and ors, involve formulas that we don't necessarily use in this class. We evaluate these types of probabilities by looking or examining tables, and they don't require formulas. So it's more of a thought process than using any kind of formulas. We will look at the formulas for ands and ors when we talk about frequency distribution in the next section. So right now, we just want to focus on looking at the tables and figuring out ands and ors and regular theoretical probabilities without any kind of formulas. So an and probability is an idea that both events have to be true at the same time, or that there is that overlap when we talk about a Venn diagram. The or probabilities are when one event or the other is true. They can both be true, and at the same time, if they're both true at the same time, then we have to remove the overlap if one exists. They can also be what we call mutually exclusive, which is what we talked about in our Venn diagrams. So let's look at, so we have table 1 and table 2 here. And so we have some questions for table 1 here on the left-hand side. And so it says here that we want the probability of a female who has no drink. So this is actually an and probability because we're looking for these both things are happening essentially at the same time. They're existing together. And so we're going to look at this and we want to find the females with no drinks. So the females with no drinks is this value here. So this is the total number. And so we know that this probability is going to be, so now the probability of it is going to be 1,000 or 13,310 over the total is 27 or 200 or 27,268. So again, this is a theoretical probability, so we leave it in fractional form. We do not need to simplify this in any way because this is telling us the story of what's happening here. Here is just a strict probability, a theoretical probability of this time we want to know the probability of someone just having 1 to 2 drinks. So the probability of 1 to 2 drinks, there's a total of 500 or 5,825. So we know that this probability is going to be 5,825 out of a total of 27,268. This time, the word and is actually put into the statement, and the word and doesn't have to be put in the statement for it to be an and probability. So notice here, the and was implied, but in this one, we actually state the and. So we want 3 and 4 drinks and males. So now we're looking for the males that have 3 and 4 drinks. And so that probability is equal to, oops, cursor doesn't want to go there. We have 912 people out of a total of 27,900, or sorry, 268. Okay, so now let's look at table 2 and the same idea. So this time we have an or statement, and our or statement is we want a psychiatrist or a lawyer. So we need a psychiatrist or a lawyer. Now these two professions do not overlap, so we have a total of 118 psychiatrists. We also have a total of 105 lawyers. So we know that the probability of this And the or probabilities are always going to be larger than an and probability. So we know that we have 118 of psychiatrists. We also have 105 lawyers. They don't overlap. So that's out of our 635. So 635. So that gives us 120, 100, 200. My addition is not working right now. So we have 223 out of 635. This time we have left-handed dentists, so that is an and statement. So this one is a left-handed dentist, and we're implying the and here. So this is implied and it's not written. We have to know that these two things are happening at the same time. So a left-handed dentist is going to be 10 out of the total. So we have this is equal to 10 out of 635. Now for the last one, we're going to look at actually, I think I'm just going to do it in black. We want a lawyer and or being right-handed. So we know that there are 105 lawyers. We know that there are 536 right-handed people, but we also know that we have 83 lawyers that are right-handed. So if we count them in the 536 and count them in the 105, then we've double counted them. And so we need to eliminate one of those counts. So we know that we have 105 plus 536, but we got to subtract out the 83 because we have double counted them. That's that overlap. And this is out of 635. And I'll let you guys do the top calculation there to figure out what the numerator is out of 635.